Welcome to today's webinar. The topic today is wind simulation in RWIND 2, modeling, wind load generation and documentation. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. I've been working for 12 years for Dlubal Software. And yeah, I will be the moderator today. Maybe I say some words about my work. I'm responsible for the website, the German and English webinars, customer projects, and so on. And I will also answer your questions together with Andreas Niemeyer, and Stefan Hoffmann will do the presentation, but they can introduce themselves.
Okay, thanks, Andreas. So my name is Stefan Hoffmann, and I'm working for Dlubal since 2020. And I'm mainly doing customer support, answering your questions via email or telephone. And I'm also involved in the development of form finding, membrane structures, and as well a wind simulation. And today I will be the main speaker of this presentation, and I will hand over to Andreas.
Andreas, it's your turn. Can you introduce yourself?
No, sorry, micro was off. Hello,
Okay.
my name is Andreas Niemeyer. I'm working for Dlubal, I think, up to 16 years now. I'm responsible for the product engineering. I'm taking care about not almost, but many wishes. And additionally, I take care about the wind simulation and form finding applications.
Okay, thank you for your introduction. Then we can switch off our webcams that the attendees can see the full screen. Yeah, for all the people who attend the webinar the first time, you can show or hide the control panel on the right side of your screen. And if you want to enter a question, just enter the question here and we will answer you. If you don't get an answer during the webinar because there are too many, you will get an email afterwards. The other way is to watch the entire webinar and then email questions to info@dlubal.com. To the agenda today, at first, Stefan will give an overview of the new features in RWIND 2.02 Pro. Then he will do a wind analysis in RWIND Pro without using RFEM 6. Then in the next step, a wind analysis in RWIND Pro in connection with RFEM 6. And he will give a prospect, what we schedule to integrate in RWIND in the future. Okay, then I hand over the screen to Stefan and he can start with his presentation.
All right, so thanks, Andreas. So today it should be already working that you can see my screen.
Yes.
Hopefully. Okay, so then I will continue with the next slide. So I have prepared a PowerPoint presentation for you, which will sum up the main new features of RWIND 2.02 Pro. So this will be an overview for you, and you will then be able later on to download the PDF file and to double check it if you are interested in the main features. And I did also contribute the website links into the slides to our online manual. So mainly we are not working with a printed document file as a manual, but you will get the chance to visit our website and to search for the help and also the manual on the website. So this is only a list of new features. So it's just a selection. There will be some, or there were more features. So we added a context sensitive help. So you can just hit the F1 key on the keyboard and this will directly open your website browser and you will be redirected to the topic of the dialog you're checking at the moment, and you will then find various information of this topic. Moreover, we also added batch processing, so you can just create your models. You do not have to click and calculate them one by one, but you can save time. So if you are curious in doing some batch calculation and to compare different wind speeds or whatever on a single file, you just have to save the file under a new name, and then you can just run your 10 example files in the batch calculation while doing some other projects or whatever you want to do, drink a coffee. Last but not least, I will later on show you the new graphic model editor, and also a model library was added into this version. So the first new feature I want to talk about on the slides are the permeable surfaces. So these are surfaces with a pressure condition where you can then simulate a pressure drop on the backside of the surface to reduce the wind speed, because there are some textile membrane or something which is not fully closed but also not fully open, and then you can simulate it. I will go into detail on the next slide. We did also add some load factors for zones, so you can now modify the loads directly in RWIND, and if you're then using them in RFEM, they will be increased or reduced by these load factors you are editing into the model. So this will save you a lot of time, so you do not have to create your own loads in RFEM, but you can then already have the reduced or extended loads in RFEM 6. We did add some point clouds. So this is a preview picture on the right of a tube where you can also track flowing particles in the analysis, so in the transient flow analysis. So you can have a clue on where the wind is coming from. It's also available then for streamlines, and where the wind is going to. So it's a quite good tool to follow your wind particles. I will have, of course, an example file later on. The next feature is the convergence criterion. So currently, we stop the calculation after a certain drop of pressure. So if the difference to the latest iteration is on a certain kind of a value, then the calculation will stop, giving you then the results. And since this is not suitable for every stationary calculation, we added some new type. It's about the drag force difference on the model. Moreover, we added some extended model information. So you can right click on your model and get some information about the area or some other useful information. I will later on show it, of course, in an example. There are some new auxiliary objects, so you can add some comments or also dimensions to your model. And last but not least, as a feature I want to show today to you is the graphic model editor, which will allow you to directly model in RWIND. So you do not need CAD software, or you can also use RWIND besides using RFEM 6. And this allows you to create some models and as well to create a terrain with thickness vectors. So whenever you also are curious in modeling the terrain and to have a knowledge on what effect will the terrain have on your model and the wind flow, then you can directly as well do this in RWIND. So let's go to the first slide, which is gathering some more detailed information. As you can see, I have put some links on the top right of the slide. They can be clicked, and you will then be directly guided to the topics of the online manual. And these newly introduced surfaces are meant to be introduced for zones as a material. And you are supposed to enter 3 parameters, so the Darcy coefficient, an inertial coefficient, and the permeable media length in the flow direction. And you can see on the right how these formulas are put together. So it's about the permeability in square meters and some Fruchheimer parameter. Of course, you will have some preset of data. So there is some standard of values introduced, but of course, it's up to you to calculate these parameters and to enter them for your zone. It's mainly meant to be a boundary condition, and it's a prescribed pressure drop on a defined surface, so front or behind. And the main advantage we see in this permeable surfaces is that it's no fine modeling necessary of your permeable structure. So you can imagine it allows you the simulation of scaffolding tarpaulins, dust protection curtains, and or mesh constructions, which are usually on a quite thin structure, thus leaving you with our 3D solid mesh to have a quite fine mesh, at least at these areas. And of course, you can go wider the longer you are away from this construction, but still this will increase a lot of finite elements. And with this definition of the permeable surfaces, you should get just rid of a fine modeling, and you can of course do your own structures there. So I will now switch in my example files for this feature. So on the top, you can see the velocity, and as well in the bottom, it's scaled on the same type and on the same number. And I've just used the example model, which is as well installed once you install the version. So if you are not aware of it yet, you can just go into the project manager and as well hit or switch to the demo folder. And there you can see already some examples which you can open. They do contain results and they do as well contain inputs. And I've just used this permeable surface. So on the top, if I switch or rotate it a bit, it's really from the model. Well, I usually tend to click on the bottom. So I clicked, of course, once again on the lower model. It's only an outer surface and an inner surface. And it is defined, as you can see, always on the bottom. So I will continue just on the bottom. It's having two zones, so a default zone and a green one. It's a permeable zone. And if you double click into the zone, you can see that the material 2 is here assigned for this inner surface. And if we hit into the edit material dialog, you can see that we now consider in here for this middle part the permeability. And I've in the lower file not changed the preset of D and India. I've just increased the media length into the flow direction to 0.6 meters. And on the top one, to just have a quick comparison, I have decreased it to 5 centimeters. So what we now would expect, the thicker, of course, the permeable surface is in flow direction without changing the other parameters. The slower the velocity should be in the back of the surface. So it's, of course, thicker. So it should decrease my velocity. And I will just compare them once. And you can see then in the velocity drop that on the thinner permeable surface, you have a higher velocity at the back side of the surface. So it's letting more wind going through, or it's not slowing it down a lot. And if it's thicker on the bottom file, you can see that the velocity reduces, of course. And this will then more or less simulate that there's some curtain or something in there which is blocking the wind. All right, so let's jump back into the slides and go to the next feature I already mentioned. It's the load factor for zones. So it's a post-processing factor by which you can increase or just multiply the load of the zone. And as already told, of course, it's able to be increasing or decreasing. You can also set it to 0. And I've, of course, prepared another example, which already contains results, because the calculation usually at least takes some seconds or some minutes, depending on how big your file is. But I have already, of course, calculated them. So it's just a rectangular building or just a structure where you can see that I have a default zone in blue. So I did not touch this. And I have defined some more zones. So I have half of my front. On the right side, it's my right zone, it's green, and the left zone is yellow. And I have some purple stuff on the side. And then once you have defined these zones, so like having your permeable surfaces, you just can double click into the edit zone bar, and maybe you have already seen the factor in here. I've chosen for my right green side, so half of the front, that the factor should be 0.5. And compared to this, the factor on the left should be 1, that you, of course, see quickly that it's adjusting the results. And just by chance, I have erased the sides to 2. And if you then check the simulation results, you might already experience a color change in those zones. But the best thing is, of course, to evaluate them one by one. So hitting on the right zone and showing the drag force, you can see that this area is gathering roughly 11 kilonewton. And if you hit onto the left zone, it's 20.3 or 23 kilonewton. So it's doubled because we reduced the right side by a half. And you could, of course, also evaluate the sides. But this was just as an example that you can, of course, also adjust multiple zones. And the main focus for this is, imagine that maybe the wind analysis has some weaknesses, because if the steady calculation or stationary calculation can maybe not really gather the suction at the backside of a building, you could just define a zone there and increase the value. Or if you think that you will have to add some special safety factor, you can as well increase it. Or if you think it's way over the top, you might decrease it. And then if you hand it over to RFEM 6, the loads will also be then with the factor. So you do not have to rearrange or to multiply them then later on in RFEM 6. I will go to the next feature. So it's also a quite interesting evaluation feature. So the point clouds, these are most likely just some graphical objects which you can put in there. And this area contains a special amount of points, which will be evaluated later on. And you can gather the information of your streamlines. So maybe you're used to the streamlines to see how the velocity changes or how the wind is flowing. And you can then also see some flowing particles only for the transient calculation. And those flowing particles, they can also be displayed at any time layer. I've also prepared an example. I hope my laptop will be capable of it. So it's a small wind tunnel where I have a 1 meter opening at the front. So the wind will go inside there, and I have a 45-degree triangle in the middle, and it will then be split to 2 flow directions, one on the left, which is 1 meter times 1 meter, and the one on the right is 1 meter times a half meter. And of course, with such guiding wall at the right, because I wanted to see how the particles will be flowing once I will guide my wind into this tunnel. It is important that you go into the simulation parameters if you want to track the particles as well, and go into the particles tab. And there you have to input the number of point clouds. So you can write 1 to 3 because we have 3 point clouds defined in this example. And you can hit that you want to track the flowing particles. Once again, it's only available, this particle flow, for the transient calculation. And once you have results, so let's load the results for the streamlines shortly. Then you can see that the graphic will be shown quite soon. Was faster. Okay, so I have the flowing particles already activated. I will go to the streamline results, and then you can evaluate how the wind is flowing. So you can see it from the start of the wind tunnel and even going to the end of the wind tunnel. And you can evaluate your point clouds one by one. So currently I'm only displaying the flow through the left point cloud, and you can see that it's not only the middle of the wind going there, it's more than the half. And this comes, I assume, since we have this smaller wind tunnel in here and it's blocking the wind a bit to the left. And then I guess the volume is also being pressured more to the left. Now we can as well in the streamlines also evaluate multiple point clouds. So we will add number 2 as well, which is the right one. It's the smaller one. And then you can as well check, of course, that nothing from the left is going to the right currently, but all of the right and also less than the half is going to the right one. You can as well also have the front one being displayed, which will only, of course, show you the same wind flow. But this is just for evaluation purposes. So you can check how the wind is going through. So I will now switch to the flowing particles for the transient calculation. And they are being displayed then as small bubbles. Let's hit cancel. You can, of course, also adjust the thickness. So I will increase it just a bit in the size. I think that you are better, or that they are better visible for you. Let's do 50 and set OK. And you can then animate them. So you can choose your own time layer if you want to with this bar. So the master time layer is, for this example, at 8 seconds 20. And you can also do a flow animation, which would then, of course, show you how these particles will behave. So you can see that they are more or less being created in here and then choosing their way to the left or the top, the right, of course. And you can also see the velocity. So they are more or less being put on the surface, slow down a bit, but then being accelerated once again and flow through our animation. All right, so let's switch back to streamlines that it will not slow down my computer. Okay, so the next feature I want to show you is the convergence. So you can, or you are maybe used to the residual graph, which is shown once you do the calculation. So it's, of course, doing or trying to find some equilibrium. So the pressure which is put in the front of the wind tunnel should also come out to the end of the wind tunnel. And once it reaches some value, so the standard value for pressure is 1 times 0, 1 times 10, or 0.001. And for the new drag force, which is related to the primary model, that's up to 0.0001, so it's a bit lower. And for this rectangular building, which is a bit angled into the wind direction, you can see at the backside that there will be some vortex. And for this one, you can see in the pressure drop that this will not really converge to the residual, which is set. So I have chosen to have 500 iterations, and even after 500 iterations, you will get the warning that it did not converge, and you have to check the results. And you can see the light blue, which is the drag force. You can see that this will reach the standard residual value roughly about 340 iterations, and then stop the calculation. This is, of course, only a convergence, and it's still up to you to check if the results will then be usable or not. So this is my example. On the top side, you can see it's the convergence into P, so the pressure. So this is set in the simulation parameters for the steady flow in the residual type, and also the target value. And if you hit or evaluate the residual, you can see in the top file, it did not reach the convergence. So it was set like this factor. And then you gain, of course, information, and you can see that the drag force is this and the pressure is this on your structure. And on the bottom one, I have set that I want to have the drag force being our target value with the standard value which is introduced, and it should maximally calculate 500 iterations. And you can see in the diagram on the bottom one that as shown in the main one, it converged earlier. Having a look on the factor you set. And if you then check the pressure drop or the pressure forces on it, you can see that the drag force is a bit lower. But still, for this example, I would have some more iterations, because as you can see, the drag force is still falling, but it's not being most likely horizontal. So even if you add our standard criteria, it depends on the depth of the mesh and as well on the structure, how many iterations you run. It's only most likely a stop of the calculation. So it might be that you still need some more iterations. So let's jump to the next information I want to show you. It's the extended model information. So I'm showing the car, which is from the examples, and we will provide some more information for this model. So the model area in total, the projected area in YZ, so it's in the wind direction, and also in XY, so it's from top to down for the primary model and also for the simplified model. So the simplified, just to put it in a nutshell, is the triangle structure, which is put as some overlapping structure over your model, which will then be put into the wind tunnel, because then you can give us some information about the pressure. And you can as well show the drag coefficient downwind from the primary model, so in the wind direction. So let's jump into the model. As meant, it's just the one, so the Volkswagen from the examples. And if you then see and double click on the model, you just have to go into the info tab, and then you can see the area. It's also, of course, available the dimensions for everybody who's not aware of it yet. If you want to check if your model is properly scaled, you can as well, of course, check the dimensions in there. And it's giving you some area in the projected directions, and as well the drag coefficient for your model. Okay, so let's go to the next feature. It's as well, of course, the goals displayed. These are the new auxiliary objects. So if you are giving a model to colleagues or to some customers, you do not need to add these things then later on after doing some screenshots or taking a snapshot of the model and later on putting it in with some programs. Now you're allowed to use dimensions, which can be put on models, so on objects or on the mesh surface. You can add comments free into the area or also attached to objects. And you can measure distance as a polyline. And then you can measure distance between points on the model and or the mesh surface. So let's also jump into this example. So this is the Volkswagen again, and it has a shark antenna. So you can see you can also switch the color. So if you double click on it, you can also change the font. So you can make it transparent, and you can add the frame and just hit OK. And of course, this will then be adjusted. So whatever you like, you can introduce there. And you can also see that we there have our dimensions. So let's just hit the navigator that you can see that these are introduced. So if it's mandatory for you to display some dimensions, you can display them as you can see in here. And last but not least is the measure distance tool. So if you're interested in how wide a screen is, you can just hit it and try to hit some points of the triangles. And as you can see, it's a polyline, which will give you a total length at the dialog of the line and as well the different or separate line length. So it's quite useful to quickly measure on your object, so you don't have to jump into the information, but you can see that this triangle is roughly 30 centimeters. Okay, so last but not least, on my slide is the graphical model editor. So this is most likely newly introduced into RWIND as well, and this allows you to get rid of expensive CAD software. Well, no, of course not. But it's a quite useful tool if you want to model easy objects. It's of course not that experienced like AutoCAD or Allplan or RFEM is, but you can quickly enter some objects like nodes, curves, surfaces, and solids, and even do some intersection. You can also use modeling tools which are known to you, like copying, moving it, rotating it, and mirroring it. And also a main feature is that you do not have to create your terrain in a CAD software. You can create it quickly in RWIND. And if it's, let's call it simple terrain, then you can define the topology based on graphic objects and thickness vectors. So let's jump into the example file. I just want to quickly show it in here because after that we will switch to create our own solar panels. So you can see that if you right click now on the model, you can insert a new terrain or editable model. I already did this, so I will open this one in the model editor. And you can see that I have there a solid. And I have the chance to insert objects like points, circles, lines, surfaces, solids, and so on. And I have also the option to move it, rotate it, mirror it, and also to intersect something. So if you already downloaded the version and you're curious why I have text besides my buttons, it's a smart tool to activate this in the View tab, where you can switch into Navigator and see the edit bar options. And there you have the possibility to show the icons as well with the text, which is quite smart because, well, I'm not a graphic guy. I also want to read what is written in there if you're just new to the program or not used to the program. And then you can see the text, which is then explaining, of course, the symbols. So you have, of course, also the option to change or edit your model. I will leave it as it is. And as already told, you are also able to insert the terrain. So we can also open this in the model editor, and then you can see also your construction and that you have some thickness vectors in over here. And that's quite easy then. You can, of course, also define the amount or later on copy some more thickness vectors into the terrain to simply modify the nodes. So if you double click it and you think that the thickness of the terrain is 6 meters in there, you just adjust it. Or if you are crazy and you put 20 meters in here just for visualization, you can see that you will have a small mountain. And this model would then be also taken for the wind tunnel, and it can then be used as well as a lower boundary condition for your wind tunnel. And the wind flow will then flow, of course, and interact with the terrain and then be put on your building. And it might be quite useful or necessary to also take into account the terrain maybe. All right, so this will most likely sum up the overview of the new features. Time already passed as well. And now I want just to jump into the program by creating a new file. So let's go back into this one. Let's close it, don't save it. And I just opened the program now, and we will go and hit a new project. Let me shortly open my file where I have my steps, that I do not forget anything. And let's give it a name. I'm usually used to write my date in there. So it's already soon or close to Christmas today. Only some weeks missing. And well, I will call it Solar, my file. I hope it's not named already. And usually you would then hit the import model from a file, or usually start in RFEM and transfer your model directly to RWIND. But I want to start with a blank sheet at the start. So I would have to define my wind tunnel, but I will just leave it as it is because I will later on adjust it to the model. And then I have my clean or blank file. And as already told, we also have a model library. And if you also want to reuse your model, you just have to go into the File tab and open the model library. So you can see I have already, of course, tested myself in introducing my model. And there are some core models also already available. And in the model library, just hit the new button. So you can now use a name. So let's call it Solar and 08 for today's day, and hit OK. Then you will get a domain type. So the layout one will be for the terrain mainly, and the general one is for your normal 3D solid mesh. And you could as well already define an initial workspace. So we'll just leave it with the standard settings and then zoom out a bit. I'm usually not used to the perspective view, so I'm just doing the normal view. And the first thing I would do is to adjust my grid and workspace, because as you can see, the presets are 0.5 meter, but I will just increase it to 1 meter. So it's just the dot, the distance of my dots. And then I can start to model a blank file. So I would just start with a line, connected systems, and my dimensions are now 1.80 meter times 1.20 meter. I could have, of course, arranged my grid to the measurements, but I'm usually used from RFEM to just create my rectangle, and then I will move my stuff to the correct dimensions. So as you can see, I have a 2 meter line. I can just mark the line then and use, of course, the translate option. So the X direction is usually meant as the wind direction, and I want to have it be moved 20 centimeters down. So then I have 1.80 meter. And the next line is as well 1 meter only. So I want to have 1.20 meter in there. So I'm going to translate this into -0.2 into the global y-axis. And then I have my first rectangle. So this should be some solar fields. So I have one panel, and I will now just mark everything and translate it, because the translate button also contains a copy option. So I want to have it 1.20 meter. You can also use this cursor and gather the distance quite in the graphics, which is as well 1.20 meter. And I will use 11 copies and say OK. And then I have already a half of my solar panels created. And I would then just mark everything and use my control key on the keyboard. So using the drag and drop and copy paste it to the other side. Of course, I can go back again and use the mirror option. This depends, of course, what you like, to be honest. So it's up to you using some or a lot of modeling tools. So I would just choose the plane, the XZ plane. It's of course to mirror it at the 0 point, and I will do a copy. This will give you the same stuff. Well, I think drag and drop is easier for such a easy structure. So I'm used to do the drag and drop. So once you have it, I will mark everything and create planar surfaces. It's just giving me a dialog and information that I've now 24 surfaces created. I will move them because they are standing a bit in the air. Don't forget, if you only want to move, you have to remove the number of copies, 80 centimeters. And then I want to rotate them a bit because usually they are not laying horizontal. So I'm marking everything, hit the rotate button, and I want to have it minus 30 degrees, no copy. It's the y-axis. So of course I want to rotate them into the wind direction. And since I moved them already, I have to pick at least my node in here. It's also available only for Z, and then they will be put in 30-degree angle into the wind. It might also, of course, be not 30 degrees. Then you might now save this model, put it back, and create another model with 20 degrees if you want to do some parametric studies for your file. This could now as well already be used. So I would give the surfaces a thickness, but arranging them easier in the wind tunnel, I propose just for this example to also add some columns on the upside or on the bottom of these surfaces. So I will just for this example graphically split my lines. Now I want to divide it into endpoints. So I want to have 5 new nodes. You can of course use your measurements you have, and then I want to have some perpendicular columns, so they should just go down. So you can now, for example, pick those nodes and copy them back down as one copy, and later on just adjust the Z value that you have them laying directly on the ground. You can imagine there are smarter ways or even faster ways, but I'm usually used to do some quick geometric stuff. And then I want to have quite thick columns. Just for an example, to have 20 times 20 centimeter columns. I will use this, press Ctrl Z and Ctrl V on my keyboard, which is quicker, most likely, than the translate stuff, but the translate offers some more options. But if you just want to quickly copy some nodes, like me, I want to copy it in this direction, then I can do this because I want to create a rectangle. So from my point of view, the quickest way to do so is to move your nodes to create the outer edge node of your rectangle, and then you can just enter it as a surface. You can, known to RFEM6, just mark it, hit Control, pick the node in the middle and move it to the left. And now we want, of course, to have the interaction to the top, which is then curved or angled. And I will use my surfaces and extrude them. So it's up to you to just extrude them a bit higher than the current surfaces are. So now they are solids. I don't need them for my example, so I'm going to delete them, as well as the top surfaces and this middle line. I don't need it for further modeling. And then I will use my intersections of the lines, which will give me then the connection points where my column is going through my angled surfaces. And I would then just quickly move by drag and drop my nodes down, just to fulfill that the columns will of course end at the bottom of my example. So there are various possibilities to do so, but well, I gathered that, or I expected that this is the fastest one for me. All right, so now I have in the middle of my solar panel, like having a satellite, some columns. So I will mark them and then copy paste them by hitting the Control key on the keyboard on the places where I need them. And of course, I do not want to have my columns standing out of my solar panels. So I will use them. I will use them. Yeah, I will mark them, and I will the translate button, and I want to create one copy, and I use my move tool. So this outer edge node should maximally go to this node, and then I do not want, of course, to move it into X or Z direction, because I only need to move it into the Y direction. And if you do so, you can see that it's now there. So I have my columns for half of the structure. Now I'm going to mark them once again and only to mirror them into the XY plane, and my copy is still checked, and I hit OK. And then you can see that I have now modeled my columns beneath the solar panel. So what I am finally going to do is to give my panels some thickness. This can also be done with the tools. So I will extrude the surfaces perpendicular to their angle, and I will use a thickness of 10 centimeters and say OK. All right, so that's it for this model. And then you just have to hit save, and you can close it. So we saved it into the model library. So we are going to insert a model now from the library. And there is our Solar 08. And then take care that you do not check that it will be adjusted to the dimensions of the wind tunnel. So this option is mainly meant if you already have your model and you want to insert some other objects, that it will be scaled. But we will have, or we want to have, our solar panels in the correct shape. So if you double click on them and hit the info button, it should have the area which you will expect. So it's now introduced, and I first double click on it and tell it that I want to have a level of detail of 4. You can see later on what this will do. And then I want to have it 9 times in a row. Before I do that, I just want to arrange my wind tunnel, so the flow domain, to be adjusted to my model standing on the bottom, and hit OK. So it's then, of course, arranging or readjusting the wind tunnel to your dimensions. So what we now did is, if I quickly only for this one panel show the simplified model, is that we have then our simplified model around it. It's not that smart. You can see it's closing some gaps, but for a quick estimation of the wind forces on my panels, it's quite useful. I will uncheck it again, and then I will hit my solar panels, and I will use the move along vector, and I will move it 3.1 meters into X, and I want to have double check 9 copies, of course, say OK. And then you have quickly your solar field with a gap between them that some people can walk through if they have to clean them. And you can then once again hit the flow domain and adjust it standing to your models in the ground. So it's usually adjusting the standard sizes. You can then, of course, introduce your simulation parameters. So I will keep the standard stuff. Usually would, of course, then go and define a wind profile according to your location, which can in RWIND only be put in manually. If you use it with RFEM, you can see that you can define the wind profile by your own, and it's listed according to our GeoZone tool. So I did not do any big changes in the simulation parameters. And I have, of course, already calculated it once. So let me hit into the webinar and hit it without the terrain. And you can then later on see, of course, that for your different solar panels, you can see that you will get your track force, the pressures, depending on the color scale. And if you check then the velocity field, hopefully it's not loading that long, you can see that the first one is working like, let's call it a car spoiler. So it's rearranging the wind to flow over the panels. So the first one will get a higher wind track force, of course, and the other one are standing like in the shadow of them. Let's call it like this. So behind the first panel. Let's see if it's loading quite long. It's quite bigger file, of course. Laptop is already making some noise. Oops, maybe I should have closed the other examples. Okay, so there it is. So the scale is a bit misleading maybe. So if you hit some other ways in here, well, I will not rearrange it. You could see that, of course, the wind is then being redirected from the first panel quite over all other panels. Okay, so let's close this with examples. And now I want to introduce my terrain. So I just hit right click on the model and I introduce a new terrain. You can give it a name or not, depends on you. And then you have to type an initial shape in there. So what I want to do is to have it from -45 meters up to -5 meters. I did, of course, priorly checked where my model is standing, and I do some inputs for my thickness vectors. I only want to have some stair terrain, so I do not need a lot into the Y direction, and I hit OK. And then you can check from the side to see where the solar panels are standing. And in our example, I just want to raise a half of this terrain with the thickness vector to be moved ½ meter top. Yeah, ½ meter top. So if you're entering, of course, it with a dot, then it's not giving you the warning. And the last 3 ones should also be moved ½ meter on the top. So you can see with this terrain editor, you can just quickly arrange a staircase terrain, or if you have some other crazy shape, you can of course also use those thickness vectors. And I will save it. And now it's of course laying somewhere. So I will once again adjust the flow dimensions and say OK. And then I will just, or it's leaving me just to move my main solar panels a bit higher because I have entered a minimum thickness of 1 meter of the terrain. So I will just move them along a vector. So I will not create a copy this time. And I just firstly move them 1 meter higher. And the last 6 will also be moved ½ meter. And well, so of course using the comma and entering them once ½ meter ago. So as you can now see, I have a staircase of the terrain. So the first ones are standing down ½ meter higher, 3 ones, and once again ½ meter higher, 3 ones. So the calculation with this detailed mesh took roughly an hour, but I did of course already create or calculate results with the terrain. So you have to trust me. But you can see from the side that of course I have this staircase terrain. And then you can see that the drag force of the front panels, which are lifted a bit higher, are of course changed a bit. And this gives you most likely an option to take into account the terrain. So sometimes this might be necessary and sometimes it's maybe not necessary, but this is up to you. This can be done mainly also in RWIND standalone. Okay, so let's leave RWIND standalone because the time is running, but we are quite good in time. I will just quickly close my RWIND stuff that my computer will not crash down. Okay, and let's go into RFEM. So this is the model. This will be later on as well be uploaded on the website. And this one is maybe known to you from the seismic analysis. So I did not create a new model. I did just modify it. It's a reinforced concrete building with some steel attachment. Let's call it like this. And I have used our node transfer surfaces because I will have some facade, which is only giving the wind loads to the down structure and not giving any stiffness into my structure. So for my purpose, I will use those purple surfaces. And I have, of course, then defined maybe if some members are not carrying loads like those tension members in here, or if my only couplings should get some force or not. So this is the stuff I have introduced, and mainly, I will now show you what inputs can be done to RWIND and RFEM6 directly. So the first one is, of course, to activate the wind simulation as an add-on in your add-ons. And then you go for a location. So I have chosen Leipzig to be the location, which is already loaded in our model. And then you could already here define a terrain. So if you're not doing anything in here, the 0Z plane will be a horizontal plane. You can enter some offset plane in here as checking maybe some parts of your model only, or if it's standing somewhere higher or lower. You can also have an inclined plane defined directly in RFEM6, or you can enter some table values. I think this was already once shown in another webinar, which can then be as well be seen on our website as a record. So for our example, I will not, for this purpose, use a terrain. So I have now defined my location, and then I will have to go into a new load case. I will, of course, use now a wind load case and have the analysis type wind simulation. This will give me some more tabs on the top. And then it's intended to work from left to right. So the first thing you can set is the wind simulation analysis setting. So you can just hit to edit them. And we will not divert into the steady flow or transient flow, because I think this was already shown once in a webinar. But you can then, of course, adjust values if it's necessary for you. So those are then, of course, being transferred into RWIND. And you can as well also adjust the turbulence model and some other parameters which are put to RWIND. So we will just leave it with the standard settings. You can also jump into RWIND. So if you want to double check how the structure is going to look, well, of course, we have to define some other stuff for it before, then you can click this button. And you can also create a new wind profile. So if it's user-defined, we could enter something like an RWIND, or we can now choose our standard according to the German location we have set. And then you can see that the table values of velocity will automatically be calculated and the turbulence intensity. Mr. Niemeyer did also provide a smart technical article about the dust principle, I think, according to the German standard, which is available also on our website. You can as well print these graphs into the printout report if you want to, but we will create it later on. So we will just define the wind profile, hit OK, and we will leave the 0-degree direction. And well, you could as well, if you want, to adjust the wind tunnel. So if we would put this into the wind tunnel, it will put everything what is visible into it. So we would have most likely our member shapes being on the outside, but we only want to have our surface being transferred. So what we now need to do is to go into the calculation and the mesh settings. And there is a new tab if you have the add-on activated, which is called Wind Simulation, where you can choose if you want to close openings, have a level of detail, or add also an IFC file as terrain or a surrounding model, or as well consider the surface thickness or run it in the silent mode. We don't want to run it in the silent mode, and we want only to export visible objects. So if we now want only to have our surfaces, the quickest way from my point of view is to activate the visibility where you display all members. So you can see only members now. And then I go and show the reverse visibility. So now I can only see, as you can see, hopefully, my surfaces. And this outer shape will be given to our wind. We have now defined one wind direction. So the next way might be that you just copy your wind direction and enter some degree or some certain rotation of your model in here. And you can see that, of course, the load will rotate. The quickest way to do it is the wizard. So I think you can just create a new load wizard for your wind simulation, and this will do it automatically for you. So you don't need to copy, enter a new number, copy, enter a new number. You will just add your wind simulation analysis settings. You enter your wind profile, and then it will create all the load cases. So 10 degrees is maybe a bit high. Let's do 45 degrees. And then this will create all the load cases for you. If you hit OK, so this will save you a lot of time. We will not calculate them in this file. Okay. So I've just quickly create a new printout report. There was already a webinar about it. So it is now also being able to be modified once RFEM is opened. And let's open it. There you can, of course, then evaluate your data. I will not show how you can multi-print something in there. But I would just want to show that you, of course, can print your wind profile in there. So if you're displaying it, you can just print it into the printout report. You can get a preview of it, and you can hit Save and Show, and you can see that the pictures are smartly printed into the printout report. All right, so we will not run the analysis now in the program. I have, of course, already results for my file, because this will as well take some moments to calculate. And once you have finished the calculation, you can, of course, also evaluate the results in RFEM. They are then being transferred back into the program. So we will now have our normal wind load, which is put on the building, so you can see the deformation. Or the best thing to check is that you can also check the distribution of loads, which is yet available. Let's call it only for surfaces, of course, and not the transfer surfaces. But if you want to evaluate the results of your members, you can just also go back, cancel the visibility mode, and check the member forces, so maybe the global deformations. So I have quite a big load going sidewards on my own member, so I may now think about adjusting my static system, or maybe the load transfer, how it is put on my surface, because I think I've not excluded the top bar, but the facade might be fixed to the outer edges, and then of course the load will be gone. And you can of course also see then the internal forces, like the shear force, so the force into that direction, which is then put from the facade, from our load transfer surfaces, as I have defined it in here, only to the columns. And this will then, of course, be available in your static analysis. All right, so this is most likely what I wanted to show you, how to use RFEM6 with RWIND. So more information can as well be gathered on the website. What I now remember is that I missed to show you that you can, of course, as well print stuff from RWIND into the clipboard and use it for documentation. But the printout report in RFEM is quite better, most likely, because this is meant to calculate the wind loads, get an estimate, and using it with RFEM6, or maybe do your own graphic snapshots in here and to document it. All right, so I will jump back to my presentation, because I'm coming to an end with my content, and I want to show you the prospect, what is planned in our development. This will not be ready in days, but well, this is just the way abroad, how it's called. And we are planning to import as well experimental wind tunnel test data in order to be capable to validate your investigations, because it's a quite controversial topic if it has to be the loads according to the Eurocode, for example, or not. But the best way, of course, to validate a finite element analysis is to have a real model. That's the only way leaving it to you, or to have a solution for something. This should also be able then to be transferred as or to transfer the test data back to RFEM6 as well. So this will save you a lot of time if you have a wind tunnel test data, that you do not have to enter a lot of nodal loads maybe to get your wind tunnel data into RFEM6. The next big part is that we plan to have a time step calculation, which is as well already be possible with the transient calculation, but to have it being transferred back to RFEM6 and to combine it with the time history analysis, so that you can maybe check if your structure is swinging a lot over the time, and if you have to take some more construction steps to fix it or not. And last but not least, of course, this is not a full prospect, it's just some highlights I want to mention. We want to have an envelope of the results, so maybe for all time steps that you do not only check the master time layer, but multiple time steps and see where are the maximum and minimum forces, and or to have it for different wind directions, which will then be easier for you to evaluate. All right, Andreas, I think I'm some minutes ahead, but well, I will hand back now to you.
Okay, thank you for your presentation. I think we are quite in time. Before we close the webinar, I would like to show you where you can find the recording of today's webinar. In the next days, I take over the screen to my screen. Just a moment. On our website, dlubal.com, you can find under news and events the webinars. Yeah, I hope you know that we record all our webinars. You will find the accomplished webinars and so on, and upcoming webinars you can filter as well on the left side here. So that's an upcoming webinar. I search for the webinar of today. That's today's webinar. If you click on it, you will find the recording in the next days here. You will also get an email with your certificate and the link to that page here, and there will be the recording, and you already can download the presentation slides and the models. If you don't have RWIND already, you can download the free trial version here above, free trial version. You can download the trial version of RFEM 6 and RWIND 2 and go through the webinar with the provided models that you can download. Okay, that's also all from my side. I thank you for your attention. Thanks to Stefan for the presentation. Thanks to Andreas for answering the question or questions. Before we close the webinar, just a last hint. When you leave the webinar, there is a small survey. You can score us. I think it takes only 1 minute or so. You can enter your wishes for future webinars or what we can improve and so on. If you don't enter or don't want to enter anything, just leave it empty or enter a minus or something, a sign like that. Okay, then I wish you all a nice rest of the day and bye-bye.